the graph below over here, we have to suppose that you have got up from your bed and go to get your coffee. Upon bringing your coffee to the couch, you remember that your remote course is synchronous and head to your deck. Once at your desk, you realize that you have left your computer on your nightstand and quickly grab it and return to your desk. So everything happens in 40 seconds. So what is the total distance, displacement in meters? Remember, the displacement is only the difference between the final position minus initial position. So displacement is going to be the final position minus initial position. Final position is over here, which is clearly 3 meters from the bed, and the initial position is definitely uh I think it's 0 over here. I'm not sure. It looks like 0, so I'm going to take it as 0. So that is 3 meters. Now, for the distance traveled, which is part B, remember the distance is not same as displacement. That is actually the distance which is being traveled. So from here, it started traveling a distance of, it traveled a distance of 2 meters. Then it didn't travel anything. Then it traveled a distance of again 3 meters, so a total of 5 meters till now. So at this point, till this point, A, it traveled 5 meters. Till A, it's 5 meters. Then from A, it started traveling once again. So from 5, it went to, if you realize, it went to 0 once again. So 5 to 0 means again it traveled for, till point B, in fact it traveled for 5 units, I can say, because it again came from 5 to 0. So from between A and B, it traveled for 5 meters once again. And finally from B to C, once again it traveled from 0 to 3 meters. So between B and C traveled for 3 meters. So the total distance is 5 plus 5 is 10, 10 plus 3 is 13 meters. And for part C, what was your lowest speed and the highest speed? So for the speed, we know that the speed is uh, nothing but the distance traveled over the time, uh, in this particular case, the distance is not changing, so the speed is 0. In this particular case as well, for this interval, speed is 0. For this interval, speed is 0. For this interval as well, speed is 0. So let's consider the speed over here as v1. This is v2. This is v0. This is v3. This is v4, and this is v5. Let's try to find out all the speeds over here. So for v1, the speed, like I said, is distance over time. Distance is 2 meter, and the time is, I'm not really sure. At this point, what is the time? Interesting. This is the point, and if we drop a perpendicular, it's somewhere around 2.5. Well, let's say this is 2, this is 4, this is 6, this is 8. It's somewhere if between 4 and 6, so that's 5. So speed is 2 over 5. For V2, that's going to be, the distance traveled is from 2 to 5. So the distance traveled is 3 units. Over time is from here, midpoint, to 20. Now this is 12, this is 14, this is 16, this is 18. So this is between 12 and 16, which is 15. So this is from 15 to 20. So 15 to 20 means 5 seconds over here. We talk about v3. V3 is from 5 to 3. So again, 5 to 3, it means that 2 units, that is the distance. Over the time is, this is 30, and this is going to be in between this. So this is 25. So this is 25 to 30. So this is 5 seconds once again. And for V4, that's going to be, V4 and V5 are definitely same because they are symmetric. So V4 and V5 are going to be from 3 to 0. The distance is 3, and the time is from here. This is 30. If we clear this up, this is close to, I would say, 32. So this is 32 to 33, I would say. 32 to 33, because it's closing off over here as well, which is just 1 second. So this is 3 over here. So the highest speed is 3, clearly, because That's what is coming as the highest, and the lowest speed is coming as 2 over 5, which is 0.4, and the unit is meter per second. So this is the lowest and this is the highest.